Thanks, Jasmine. Good morning, everyone. So I'm very happy to be here today to share our Alluxio use case in WeRide, show how we use Alluxio and Spark to accelerate our auto data tagging system inside WeRide. So this is the outline today. So I'll start with a quick introduction, and then I will provide an overview of Alluxio from a user's perspective. And then I'll talk about the WeRide use case of Alluxio integrate with Spark. And the talk will end with our future work and some plans. So if you have any questions, please feel free to interrupt me anytime. Let's get started. So a quick introduction of me. So my name is Feifei. I joined WeRide recently and now working on data tagging system. So before WeRide, I was working on distributed system with some experience on AWS and Kubernetes. And about my colleague Zhu Hao, so he is not able to join this session today since he works in Guangzhou, China, and now it's already midnight there. So Zhu Hao has a lot of hands-on experience with both AWS and on-prem data center services. So I'll try to cover his slides and work today. And also some facts about my company, WeRide. So WeRide is a global leading company that develops L4 autonomous driving technologies. Established in 2017, WeRide is headquartered in Guangzhou, China, and run office in several cities like Beijing, Shanghai, Nanjing in China, and as well as San Jose in the United States. So WeRide launched China's first robotaxi service, completely open to public back to 2 years ago. And now WeRide offers an all-rounded product mix of, as shown in the picture, the robotaxi, mini robobus, and robovan. So we provide multiple services, including online ride-hailing, on-demand transport, and urban logistics. So I talk a little bit about the Alluxio overview. So Alluxio is fast because it can be used as a distributed sharing caching service, provide the memory speed I/O, and in addition, the tiered storage can leverage both memory and disk, so makes elastically scanning data-driven applications cost-effective. And Alluxio provides simplified and unified data access and management. And also, it's very easy to deploy and use. The existing data analytics applications, such as Spark, can run on top of Alluxio without any code change and with simply just a one-line configuration change. So next, I'll talk about the WeRide use case. So this diagram shows a typical workflow of autonomous driving development in WeRide. So from the data's point of view, it's just like many other data-driven machine learning projects. So we collect sensor data from our test vehicle fleets every day. Then we upload to the cloud storage. Then we have data processing and analytics for data selection. Then we will do data labeling, also the HD map labeling and development. So the next step will be the machine learning model training, some AI algorithm development. We also run simulation and validation. We would have hardware in loop, software in loop. Then we would deploy both the onboarding vehicle fleets and offboarding servers. So the biggest challenge is the data size. So we generate many terabytes of data every day and accumulated from millions of Maya age, and the size would be in petabytes. So this requires vast amounts of storage and significant computing power. So what is data tagging, and what are tags in autonomous driving? So when we say tags, sometimes it can be confused with labels. In autonomous driving, tags usually means scenarios, while labels can be like obstacles or boxes. So for example, in the left image, it shows a lane change scenario, and the right one shows a right turn scenario. So we would tag this frame, usually a sequence of frames, with lane change or right turn tags. So the neighbors here would be the lane or the surrounding vehicles, obstacles, or the traffic lights. So in a data-driven autonomous driving workflow, data tagging plays an essential and important role in data analytics. So with the tagging results, we can do data selection, so to support the downstream pipelines like model training, benchmark, and long tail evaluation. So how data tagging works? So we don't have enough time to talk about the details, but basically an end-to-end data tagging pipeline is to collect and upload the raw spec files from the test vehicles and then convert it into like Parquet format. So then we can run Spark jobs to perform some data analytics algorithms. Then we can export the tagging results to downstream pipelines. So the system architecture is quite typical here. So in WeRide, we built and run hybrid cloud, both AWS and on-prem data center. So the on-prem data center is more cost-effective and also can be customized. So AWS is easy to scale. So in both AWS and on-prem data center, we use Kubernetes to manage the computing resources like the CPU and the GPU clusters. And we also use it to schedule our workflow and tasks. And in the storage layer, we use MinIO to build on-prem S3 compatible object storage service. So here, Alluxio provides a fast, simplified, unified data layer, bridges the S3 MinIO and Sparks, and also some other data analytics applications. So the test results. So this work was done by my colleague Zhu Hao a few weeks ago. So the deployment was followed the Alluxio document. So we use a Helm chart to deploy a test cluster, actually across our CPU and GPU clusters. And we configured on 42 workloads, yeah, the magic number here. And we configured to use the tiered storage. So level 0 be the memory, 50 gigabytes, not that much, but as I remember, we used to give 200 gigabytes on each host. And we configure the level 1 be the SSD and with the size 200 gigabytes. So 42 worker nodes, we end up with around 2 terabytes of memory and 8 terabytes of SSD size. And for our data tagging tasks, there was only one line configuration change, and I really like it. And we also add Alluxio into our command line tools. But actually, we want to enable Alluxio by default and hide it from our users. And overall, we have seen around 7 times faster in our tagging tasks. And so our future work contains 2 parts. So one is we want to build the unified data layer with Alluxio to do the data orchestration. So we want to integrate with more applications like the Presto, Hive, and TensorFlow. These are the services already running inside WeRide. And the other thing we are working on, we want to try to use the Spark and accelerate with the GPU and also integrate with Alluxio to get more acceleration for our not only our auto data tagging system, but also many other applications. So this is my talk today. So so the next will be the Q&A session, and any questions,